So, without telling you the topic of today's lesson, I just want you to think about how many times bigger is A apostrophe, which we call in maths A dash, than A. How many times is this bigger is this shape than this shape? Is it 2 times bigger? Is it 4 times bigger? Or some other number? Have a look at, have a think about it, and think about, could you give a reason for your answer? Pause the video now if you want more time to think, otherwise I will explain the answer. So, the answer to this is it is 2 times bigger. Now, you might look at this and think, well, hang on, this occupies 4 squares, and this occupies 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 squares. It's 4 times bigger. But look at the sides. This side is 1, this side is 2. This side is 1, this side is 2. This side is 3, this side is 6. Each side is twice as long. Okay, so in maths, when we talk about enlargements, we're talking about the perimeter. We're talking about the side length. So this it's the same shape, but it's got sides twice as long. So the enlargement is 2 times, what we call scale factor. So what we're going to have a look at today is we're going to look at enlargement. We're also going to look at congruency, but we'll come on to that later. And I think it's wise if you make a few notes on this now. So shape A dash is an enlargement of shape A. Now, an enlargement is a maths word, which means that it's the same shape, but a different size. Okay? You could have, in reality, 2 things, one bigger than the other, but they're not exactly the same shape, and you might call one an enlargement of the other. But in math, it's got to be the exact same shape, just a different size. The length of each side in shape A dash is 2 times the length of each side in shape A. So like I said before, this is 2, but this is only 1. This is 3, this is 6. We say that the shape A has been enlarged by scale factor 2. So how many times bigger each side is, we call the scale factor. So pause the video now if you want to make some notes on that. And then when you unpause it, I'll move on to the next little task. Okay, so the task I'd like you to do now is I would like you to figure out what scale factor the enlargements are. So this is 4 and this is 12. This is 2 and this is 4. This is 2 and this is 3. This is 6 and this is 3. Okay, so pause it now and then unpause it when you're ready to talk about the answers. Okay, so first thing is this is a scale factor of 3 because 4 times 3 makes 12. This one is a scale factor of 2 because 2 times 2 makes 4. Now this one, it's a bit tricky. Okay, what times 2 makes 3? Well, the answer is 1.5, 1.5. Maybe you got that, maybe you didn't. Now, how to work it out would be take this one and divide it by this one. 3 divided by 2, 1.5. Just check it works for the other ones. 4 divided by 2 gets us 2. 12 divided by 4 gets us 3. And this one's a little trick as well, because you might say it's 2, but enlargement from A to A dash is actually getting smaller. So the answer is a half, 0.5, because 6 times 0.5 makes 3. That's one little trick in maths, because in English, when you say enlargement, it's always getting bigger. But in maths, enlargement just means it's retained the same shape, but it's a different size. So it might get smaller. Okay? Right. Next, we're going to, if you wanted to draw one of these, by the way, it's as simple as I've got this shape. If this is 4 centimeters long, I'll just draw this one 12. If this happened to be 10, then I draw this one 30. Just draw it each side bigger one by one, drawing it in the same shape. And it's as simple as that. Okay, congruency. So when you can cut out 2 shapes, there's a little typo there, and they fit exactly over the top of each other, they're called congruent. What that means is, put in different words, if the shape is the same shape and size, then they are congruent. Okay, but what could be different is It could be reflected, it could be rotated, it could be flipped over, it could be upside down, but it's got to have the same sides and the same angles, and then they're congruent. If you think about these shapes, if you cut them out, could you position them so they fit exactly over the top of each other? If the answer is yes, then they're congruent. Okay, now we can't actually cut them out from the screen. So if we just have a look at the sides, we've got a 3, a 3.5, and a 4. A 3, 3.5, and a 4. A 3, a 3.5, and a 4. They're all congruent to each other. Okay, they have all got the same length. And you might think, well, hang on, going clockwise on this one, it goes 3, 3.54. And this one, it's different. But it doesn't matter, because all you've got to do with this one is flip it over, and it would look the same as this one. If you just imagine flipping it down, then it would look exactly the same as this one. If you imagine just spinning this one round, it would look exactly the same as this one. So that's congruency. Okay? If something's pointing in the opposite direction, but it's the same shape and size, it's congruent. If something is upside down or reversed, it can still be congruent. If it's a different size, it can't be congruent. So even if it's the exact same shape and it's scaled up or scaled down, it's not congruent. That's called an enlargement. Another way of thinking about it is that congruency is when you enlarge it with scale factor 1. Okay, so hopefully that's enough of an understanding for you to do the exercise. The exercise, I think, is fairly straightforward because it's fairly visual, and I think that visual things are a little bit easier sometimes. So hopefully you'll get on with that exercise well. If you don't, then just email or message me and I'll help you out where I can. Okay?